Alright guys, so as promised, here's the second example that I tried to get to in class, but we just ran out of time. So we want to find the instantaneous rate of change of this function, 5x minus 3, at the point where x is equal to 1. So recall that the instantaneous rate of change is basically the slope of the tangent line to this curve at x is equal to 1. Or aka the derivative at this point, right? So let's think about it real quick. Before we jump into it, let's think about what the answer is to this. Actually, we can find out what the answer is by simply understanding what the graph of this guy looks like, right? So you know that 5x minus 3 is the graph of a line, right? So 5x minus 3. The graph of that line looks something like this, right? So technically not a curve, it's a line. We can actually classify lines as curves, but that's neither here nor there. So we already know the answer to this, right? The rate of change at any point on this line is the slope of that line, right? And we know the slope of this line is 5. So we should be getting an instantaneous rate of change at any point on the line. Doesn't matter if it's 1, 2, 3, -5, whatever. The instantaneous rate of change for this function is always 5. So let's go through our limit process for the derivative and see what we get, okay? So the instantaneous rate of change, recall the formula is the limit as at h goes to 0 of f of x plus h minus f of x all over h. Okay. So we're going to fit the f of x plus h and the f of x to our particular function, and we're going to be looking at this point specifically when x is 1. Okay. So let's replace our x's with 1's. So we have f of 1 plus h minus f of 1 all over h. Okay. All right. Now the next step is to figure out what this f of 1 plus h is and this f of 1. So recall that anytime we have f of something, either it be 1 plus h or just 1, we just plug those values into our function for x, right? So we're just going to replace this x with 1 plus h for this evaluation and 1 for this evaluation. So let's go ahead and do that. The limit as h goes to 0 of, we're taking our 1 plus h, plugging it in for x here. So we'll have 5 times 1 plus h minus 3. Okay. So that takes care of our f of 1 plus h here, minus, we need f of 1, right? So I'm going to enclose this in some brackets just to keep it separate from the other piece. So that's my f of 1 plus h. Now my minus, and then I'm going to put in f of 1 here. F of 1 would be 5 times 1 minus 3. And that's all over h. Right. So one more time, f of 1 plus h means plug in 1 plus h for your x here. So that's what we've done. 5 times 1 plus h minus 3. Minus f of 1 just means plug in 1 right here. Okay. So I've kind of written it out, not skipping any steps there. Now all we need to do is simplify this joker. Limit h goes to 0. Right, so we're going to just expand this out and then calculate what this number is right here. So we have 5 times 1 and then 5 times h. You're going to distribute that. Okay. So we need 5 times 1 and then 5 times h. So we'll have 5 plus 5h minus 3 minus Now let's just calculate this. 5 times 1 is 5. 5 take away 3 is 2. All over h. Okay? So now that we've expanded that, we're going to try to cancel some stuff out up here. Hopefully it'll be nice to us. So we'll have the limit, h goes to 0 of, now let's see what cancels. Well, we have like terms up here, 5, -3, and -2, right? So let's do that subtraction from left to right. So 5, take away 3, that's 2. 2, take away 2, that's 0. So all of this stuff cancels, which is nice. Now you can see what we have left over. We have 5, once all that stuff is gone, 5h divided by h. Well, we can cancel out an h from here and an h from there. So all that we have left is 5. So what is the limit as h goes to 0 of 5? Well, recall from our limit laws, the limit of a constant is just that constant. So we get our desired result, which is 5. That's the slope of that line. It's always 5, right? So again, here's the entire problem. Let's recap. We needed the instantaneous rate of change of this function, which is the line with the slope of 5. Therefore, the rate of change at any point on the line is 5. Doesn't matter where you're at. Okay? So we kind of thought about that, and we got that answer there. Okay? So just be careful with this step here, right? Plugging in your 1 plus h and your 1 there for your x. That's the big step. Okay? Then you have some algebra to worry about, and then take that limit. Okay? Again, there was no h to plug in for here, so we just take the constant. All right.